Okay, welcome to section P.4 Polynomials. It's a very short section, so we'll go ahead and get started. A polynomial is a single term or the sum of two or more terms containing variables with whole number exponents. So I have an example of a polynomial here. 7x to the third minus 9x squared plus 13x minus 6. And let me go ahead and give you some definitions for certain types of polynomials. If you have called a monomial, and that would be something like x squared plus 3x. If you have three terms, called a trinomial, and that would be something like x squared plus 7x minus 9. 1, 2, 3 terms. Okay, so what I have right here in red is a polynomial. Once you reach more than 3, you just call it a polynomial. Many terms. And if we look at this polynomial carefully, we look at each term in the polynomial, and we're going to look at the coefficient of each. And we'll look at the degree of each term. What we're doing now is something we're going to be doing throughout the semester. I'm going to ask you about terms and coefficients and degree, and so we're going to go ahead and look at that now. The first term I see in this polynomial is 7x to the third. The coefficient is the number factor in front of the variable, so the coefficient is going to be 7. And the degree of the term is the exponent, which is in this case negative 9x squared. The coefficient would be negative 9. The degree would be 2. The next term is 13x. The coefficient is 13. And the degree, which is the exponent, is going to be 1 because it's being understood 1 right here. So the degree would be 1. The last term is negative 6, and the coefficient is negative 6. And the degree of the term, again, there's really not a variable that you see right here, but if there is a variable, if there was a variable, it would be x to the 0 power, because that's the same thing as 1. Remember, that's the same thing as 1. So again, the coefficient would be negative 6, and the degree of this term would be 0. If we're looking at the degree of the entire polynomial, that would be 3. That's going to be the highest degree that you see. Okay, now we're going to look at how we do operations on polynomials. We're going to look at how to add them, subtract, multiply, and divide. And in example 1, we're going to add these two polynomials. This polynomial, you can really just go ahead and drop those parentheses because you're just adding all the terms. So I really just have negative 8x to the third plus 6x squared minus 5x plus 4 plus 14x cubed plus 3x squared minus 9x minus 7. And if you want, you don't have to do this step, but you can rearrange x to the third terms next to each other. This term next to that one, plus 14x to the third. This term next to this one, plus 6x squared plus 3x squared. This one next to this one, minus 5x minus 9x. And then this one next to that one, plus 4 minus 7. You don't have to do this step. You can just go ahead and combine like terms, but some people like to do this step. So now I had to combine these two terms here, and I get 6x to the third. These right here I get plus 9x squared. These two terms I get minus 14x, and these two terms I get minus 3. So there's my answer right there. So again, when you add polynomials, you just go ahead and drop those parentheses. Now, when I subtract polynomials, as I do in part B, you have to remember that you're subtracting this, you're subtracting this, subtracting this, and subtracting this. So you're really going to be very careful about your minus sign. And so when I write this problem, I have 6x to the third minus 7x squared plus 4x squared plus 2x. Those terms, basically changing those signs. And again, I'm going to skip this step. I'm not going to go ahead and rearrange like I did in part A. But I'm going to go ahead and look at my like terms. And those two are like, so now I have 3x cubed. These two are like, and I have minus 3x squared. These two are like, so I have plus 10x. And then these two are like, and I have minus 14. Okay, when we multiply polynomials, we have to be really careful in terms of remembering our rule of exponents. So here I have this problem, 5x to the fourth times the polynomial 2x cubed minus 7x plus 3. And we use the distributive property here. I'm going to take this times to the fourth times x to the third. Remember, we use our rule of exponents. We're going to add those exponents. So I get x to the seventh. 5 times negative 7 is negative 35 or minus 35. X to the fourth times x, I'm going to get x to the fifth power. Remember, add those exponents. And I get plus 15x to the fourth. I'm going to take 3 times the 5x to the fourth. Example 2, I have that this gets multiplied by everything, and this gets multiplied by everything in that polynomial. So to do that, I always tell my students that to not forget anything, I'm going to take this 2x and multiply by all this. I'm going to write 2x times x squared minus 5x plus 25. Then I'm going to take this minus 3 and multiply by that polynomial. So I'm going to go ahead and rewrite that. I find that if you write this step out that you will make less mistakes than doing it all in your head. Minus 10x squared plus 50x. Distribute this. Minus 3x squared plus 15x minus 75. I'm going to go ahead and combine like terms. I don't see anything like this. There's no other x cubed, so I just have 2x squared plus 65x, and then this is not like anything else. I have minus 75. Term times 2 terms. And you might remember something in the past that you've done in your intermediate algebra class or in your last algebra class. FOIL. We can do FOIL when we have a binomial times the binomial. We're going to multiply first, outer, inner, and last terms. Okay? So the first times first would be these two terms right here. The 3x times 7x is 21x squared. Outer would be this term times this term. So plus 6x. Inner would be this term and this term. So I get minus 35x. And last would be this term and this term. So I get minus 10. The only two like terms I see are these two. So I just have 21x squared minus 29x minus 10. Okay, let's go through example 4 real quick. I'm going to do FOIL again. The first times first, give me 6y. Oops, 6y. I'm trying to erase this and I'm getting, there we go. And inner times inner be minus 6y. And last times last would be this and this. So I get minus 4. So these two actually add to 0. So I just have 9y squared minus 4. That's an interesting problem. We'll see this more often later on, but did you know that these are the same terms? 3y and 3y, 2 and 2, but the only difference is I have a plus and a minus sign in the middle. And so I end up getting rid of the two middle terms. So we'll see that a lot. So you could foreshadow that and see that these would be gone in the middle. If you notice that, then you notice again, we have 5x, 5x, 2, 2, but a minus sign and a plus sign. Those two middle terms should go away when you FOIL out. So you should be able to go straight to the answer and get 25x squared minus 4. First and last, the outer and inner would add to 0. If you don't believe me, go ahead and multiply it out. You get minus 10x plus 10x minus 4, and these two would add to 0. Okay. Part C, let's do first, outer, inner, and last. But you're going to notice again they have a plus and minus sign. And these terms, the end, we're going to do first times first. I get 36a to the 8th. I add the exponent because I'm multiplying. 6a to the 4th times 6a to the 4th is 36a to the 8th. And last times last would be minus 49. Again, we don't need to do the two middle terms because we know they're going to add to 0. Now, in example 5 and 6, a lot of times students get example 5 and 6 mixed up with what we just did in the last example. If I see x plus 6 to the second power, that's the same thing as saying x plus 6 times x plus 6. Pull that out. Notice how they have the same terms, x and x, 6 and 6, but the signs are both positive, so the two middle terms will not go away. And so a lot of times students will think they will go away, and they won't. So if we were to FOIL this out and do first times first, we would have x squared. Outer times outer would give me plus 6x. Inner times inner would give me plus another 6x. And then last and last would give me plus 36. So the two middle terms do not add to 0. It actually gives me x squared plus 12x plus 36. You might notice I double the middle terms. That's 6x and add another 6x. And there's a shortcut for that you can actually memorize. If you see that. Okay, so this one next here I have the same thing here. 3x plus 5 times 3x plus 5. So I get 25. I get 9x squared plus 30x plus 25. Again, if you look at the beginning of the problem here, you could just say I have first times first, which is 9x squared. And then when I do outer times outer, I get 3x times 5x, which is 15x. And you notice how you double it because you can get that again. And then last times last is 25. And so again, I don't care if you do the shortcut or do the long way. That's fine with me either way. Okay, part C, the same thing as this. Minus 4x plus 16. So I get x squared minus 8x plus 16. Again, I doubled the negative 4x. In part D, let's see if we can do the shortcut here. What we're going to do, if you want to do the shortcut, you would do first time first, we write out twice, you would get 25y squared. And then this time this is going to be negative 35y. If you double that, you'll get negative 70y. And then this squared will give you plus 49. So again, if you want to, you can go ahead and write out twice. FOIL it out. Combine the two middle terms, and you would still get the same answer. I get it a lot on the test. If you see this problem, square the x and square the 6 and get x squared plus 6 squared or x squared plus 36. Okay, they're making a rule of exponent that we didn't have. We never had the sum of two terms to a power. We had a product to a power, never sum of two terms. I'm going to go ahead and get a drink of water, so hold on for a second, I'll be right back. Okay, got a drink of water. So let's go ahead and do example 8. And we're going to go ahead and when we have polynomials with two variables, the operations work very similar to when we only have one variable. So example 8, we're still going to go ahead and FOIL. First times first gives me 2x squared. Outer times outer, I have x times a negative 3y. So I get negative 3xy. If you write negative 3yx, that's the same thing. Inner times inner, which would be this times this, the same thing. And then last times last, which would be this one and this one, minus 15y squared. Now I want to enter, so that's the same thing as this. And I went ahead and wrote it this way because these now look like the like terms. They're having the same order. I get 2x squared. And let's go ahead and do part B. Again, you can write that out twice, or you can go ahead and do the shortcut. I'm going to go ahead and write that out twice. So I get 25x squared plus 10xy plus 10yx, or xy, plus 4y squared. I get 25x squared plus 20xy plus 4y squared. Okay, so if you have any questions, please let me know. Thank you very much.